Okay, so welcome back for next session of the workshop, and this is session 2 on space technology for ecosystem health, drought and flood monitoring, early warning, preparedness and response. A bit comprehensive topic because we have really diversified presentations, almost 9 presentations in this workshop. I hope you all are back from the break and with some fresh mood again. So I would like to check if Fateme from Iranian Space Agency is there. Okay, I would like to check if moderator Professor Mohammad Reza Mobashiri, are you there, Professor?
Yes, I'm here.
Okay, good. Actually, I had requested if Miss Fateme can introduce you because she knows you very well and probably she knows your work and your biodata much better. But since she is not yet here online, so what I
No, it's
request?
here now. Yeah.
Okay, program you have there. So
I'm
because
here. I'm here.
okay, so it's 11:34. So I thought maybe it's late already. So I hand it over to you, Fatima. Please take it over and yeah, thank you.
Greeting from Tehran, distinguished participants. Right now, I'm honored to introduce Emeritus Professor Dr. Mohammad Reza Mobashiri as our moderator for session 2 entitled Space Technology for Ecosystem Health, Drought and Flood Monitoring, Early Warning, Preparedness and Response. He is a well-experienced professor at KN2C University who is academically well-known at working in the higher education industry, skilled in vegetation, lecturing, science, research, and qualitative research. A strong education professor with a Doctor of Philosophy focused in remote sensing from James Cook University, active member of CTCN, editor of 4 journals, senior researcher at Remote Sensing and Disaster Management of Remote Sensing Laboratory, author of more than 300 journal papers and 3 published books. Professor, please go ahead. We are waiting to hearing from you. Sir, Professor Mobashiri, please go ahead. We are waiting to hearing from yourself.
I think I got the wrong address. I'm working in Kabul in the engineering section as a electrical engineer. I think you selected the wrong one. I think. Hello?
Could you please keep your microphone closer to you?
Okay. So I think by mistake you have selected me as a professor because I'm not a professor. I'm working as an electrical engineer, national, Kabul. So I think I'm not the right person you want.
We have actually trouble hearing you.
Hello? Can you hear me? This is clear? Hello?
Hello?
Can you hear me? Hello?
Speak up, please, sir.
Please unmute yourself.
Dr. Mobashiri, please go ahead. I think there's some technical problems.
Yeah, he needs to unmute himself.
Maybe I should mute myself in order to have clearly a voice from the other sides.
Okay. And also,
منو میوت کنین.
yeah.
Sorry, can you hear me?
Yes, we can hear you.
I'm Said Hamza. Maybe could I start? Then maybe the Professor Mubashiri could solve the problem after that.
Okay.
I think you can do that. I think Fatima, you are muted, so nobody can hear you.
Can you hear me now?
Yes, yes.
Hello, can you hear me?
Yes, yes.
Very well. Please go ahead.
Okay. It was unmuted by the organizer. It's not my fault. Anyway, hello everybody, and thank you for this fruitful workshop. I thank organizer and all those people who are involved in this event. Because we are a little late, I start with introducing our first speaker in the second session, Dr. Said Hamza. He is going to talk about interesting topics of drought monitoring in Iran. Dr. Hamza, please go ahead, and we are 9 minutes late. Thank you. You go ahead.
Thank you, Professor Mubashiri. Could you hear me?
Yes.
And could you see the presentation?
I can see you.
And what about the presentation?
No, I can't see your presentation, but I can see you.
Okay, let's see what's the problem, because
If you have already presented your presentation, so the organizer should bring it up.
No, it's okay. It's already shared and we can see it very well.
Okay.
Then go ahead. Right now?
I can only see you.
Oh. Should I?
I think at our end, we can see his presentation very well.
Good. I can't see it. Anyway, go ahead, please.
Okay, thank you very much. Hello, everybody, and good time. Also, first of all, I would like to thank the UN OSA and also Iranian Space Agency for organizing this important webinar. I am pleased to talk about the drought monitoring in Iran using remote sensing data. As you can know, drought is a prolonged dry period in the natural climate cycle that can happen anywhere in the world. Doesn't matter that there is a dry region or wet region. It is a normal and recurring feature of climate and a slow onset disaster, which is characterized by the lack of precipitation or lack of water, with different impact from the region to region. We can classify droughts in different type, or we can define the droughts in different way. Meteorological drought, which is referred to the deficit of precipitation; agricultural drought, which is referred to the deficit of soil moisture or crop cover or crop production; hydrological drought, which is the deficit in water supplies; and also socio-economic droughts. In this presentation, I'm going to talk about meteorological droughts and agricultural droughts and their relationship, and to know which indices perform best for evaluating and assessment of these kind of droughts over the Iran. This map shows the potential for future droughts worldwide for the years 2000 till 2099 based on the current projection of future greenhouse gas emissions. As you can see here, the global warming associated with climate change will likely create increasingly dry conditions across much of the globe, especially in the areas semi-arid regions of the globe as such as Iran. And then there is a real attention for this area. Also here you can see the cumulative total freshwater losses in Middle East and North Africa, which is provided by the GRACE satellite data. As you can see here, unfortunately, most part of the Iran, or I can say whole part of the Iran, was faced with the losses in groundwater or freshwater, which is a really big alarm. And right now, Iran is faced with a crisis, and there is a need for good water resource management, and also there is a need for drought monitoring in this region. There is a variety of remote sensing data for water resource management and drought monitoring, and fortunately, most of these data are freely accessible. For example, precipitation. For precipitation, we have different kind of data: land surface temperature, soil moisture, power, and we can use these kind of data in combination with the energy balance and water balance models for water resource management and also for drought management. I'm going to talk about the drought monitoring. Over the past 2 decades, areas of satellite-based indices have been developed for regional drought for special temporal monitoring of droughts in different regions around the world has been well documented. Here you can see some of the satellite-based indicators for droughts monitoring. Some of them are based on the vegetation cover, which is very important. Some of them are based on the biomass, evapotranspiration, soil moisture, precipitation, land surface temperature, groundwater, snow cover. Then we can study the droughts in different aspects, different kind of satellite imagery. Here I'm going to talk about some vegetation indices and also about some indices based on the precipitation. Then I did this research to assess the performance of remote sensing data or remote sensing based indices for droughts monitoring in Iran, study the relationship and also to find the lag time between the agricultural and meteorological droughts in Iran, which is very important, and also exploring the best indices for agricultural droughts monitoring and assessment in different regions of Iran, because so far there are lots of research down on the meteorological droughts, but it is very important to know the effect of meteorological droughts in different aspects, especially on the agricultural land. Here you can see the climate map of Iran based on the Demarton classification type. As you can see here, Iran has 7 climate zones from the arid to extremely humid classes, and most part of the Iran is located in the arid and semi-arid regions, unfortunately, but of course we have just a small area with high humidity. Also here you can see the land cover of Iran. As you can see, Iran has a diverse land cover. Of course, most part of the Iran is a barren area, it's a desert, but in the north part of the country we have a huge area of forested area. Also here in the western part of the Iran, we have lots of agricultural lands, grasslands, also shrublands, and most probably the droughts will affect on this area more. To do this study, we used the monthly precipitation data of 153 observation stations from the period of 2000 till 2015. Unfortunately, we didn't have access to the data of recent years to do the validation. We use this kind of data to calculate the SPI based on the ground data and also to evaluate the satellite data based on this ground data. For meteorological droughts monitoring, we use the standardized precipitation index, which is the widely used drought index and very well known index. And in most reporters, actually, they use this one. Here also you can see the classification of SPI. I'm not going to the detail because I think most people know this index, and also because of the short of the time. Also, in the first part of this research, we calculated the SPI based on the ground data and also based on the satellite data from the TRMM precipitation data. We calculated the accumulated 3, 6, 9, and 12-month SPI. Also, for calculating the drought indices, agricultural drought indices, we use the MODIS product, including the 8-day LSC data and also 16-day vegetation indices data. And of course, for see the effects of droughts on different land cover, we use the land cover type of the MODIS data. All of these data were downloaded from the NASA Earth data. Here you can see that Iran is covered by 5 tiles of MODIS, then which first we mosaic all of these tiles, and after that we calculated these indices, including the vegetation condition index as an index for vegetation cover, thermal condition index, which is very important for some barren area of the Iran, as an index of soil moisture or land surface temperature, and also the vegetation health index, which is the combination of previous indices and also temperature vegetation dryness index. Here in these slides, you can see the formula of VCI, which is derived from the normalized difference vegetation index, and it is a scaling of the NDVI between its maximum and minimum values during the study period. Also here you can see the TCI algorithm, which is similar to VCI but relates to the land surface temperature, and it's mostly used for soil moisture modeling. Here you can see the formula of VHI, which is a composite index joining the vegetation condition index and the temperature condition index, and most probably it will perform better than other indices. And this is the TVDI, which integrates the vegetation indices and surface temperature to monitor soil moisture. So it has a wider range of applicability. We will see which kind of these indices perform better in different kind of Iran, and what's the relationship between them and also between the meteorological index or SPI index. Then in this flowchart, you can see the methodology of this study. We use the LSC and NDVI from the MODIS. After mosaicing, we calculate these indices, and also we use the TRMM precipitation data and in-situ precipitation data for calculate the SPI, and after that we have found the relationship between the SPI and these indices, and we try to select the best index for droughts monitoring in each region of the Iran. Here in this slide, you can see the SPI maps derived from station-based precipitation data from the ground data. As we use the ground data for calculating the different time scale of SPI, and after that we use the kriging method for creating these maps. I couldn't bring all of the maps for different time scale here. You can see just the 6 months SPI. As you can see here, during these years, the 2007 was defined as the wet year, and also the 2008 was defined as the driest year during the study period. But I really didn't want to. monitor the drought in Iran. I wanted to find the relationship between the meteorological droughts and agricultural droughts in the first part of this study. Here also you can see the SPI map derived from the TRMM precipitation data, which is the satellite-based SPI, I can say. And also, if you have a look on this slide and the previous one, you will see that there is a good correlation between them. Here in this slide, you can see the ground-based SPI and also the satellite-based SPI for 2007, for the years 2007 and 2008. As you can see, there is a very good relationship between them, and I can say we can use satellite-based SPI instead of ground-based data. Or in some area, maybe that is much better because, of course, we don't have the ground station data in most part of the Iran, especially in the mountains area, which the precipitation has a really variability. Here in these maps, you can see the correlation of station-based precipitation and TRMM, and also the correlation of station-based SPI and TRMM SPI. In most part of the Iran, there is a good coefficient of correlation. As you can see, mostly in the western part of the country, which received the more amounts of precipitation, and also the most part of the agricultural lands are located in this area. There is very good correlation, of course, in the central parts of the country, which is the arid and semi-arid regions with a very low amount of precipitation. The correlation is not very well, of course, because the TRMM basically was developed for the tropical area with a huge amount of precipitation, but still you can see that we can use it for the most part of the country. Here also you can see the time series of the average of in situ and TRMM and SPI, which there is a good relation. Okay, I'm going to the agricultural droughts maps. Here you can see the maps of the vegetation health index, again for the 6 months period. I didn't bring the maps of other indices because of the short of the time. As you can see, again, for the 2007, we have a very wet area in compare with other years, and also in 2008 we have a dry year. Exactly, there is a similarity with the meteorological drought. Also here you can see the vegetation health index of the last week, exactly the 5 August of 2021, in compare with the same weeks in the 2020 and 2019. As you can see here, unfortunately,